Video 8 deals with annuities and effective interest rates. Ben is planning an overseas holiday in 3 years' time. He makes an initial deposit of 5,000 Rand. Okay, so that's his 5,000 Rand. He puts that in at T0, the initial deposit. Thereafter, he makes equal monthly payments at the end of each month, the end of T1, the end of T2. All right. Those payments are each 2,000 Rand. How much money will he have at the end of 3 years? So his last payment is made at T36. Right? Your interest rate, A, is going to be 0,08. But now the trick in this question is your interest rate is compounded annually and we are making monthly payments. Remember, the compounding period for your interest must be the same as your payment period. So the first thing we have to do here is convert our effective interest rate, all right, because this is per annum, okay? We want to convert that effective interest rate into a nominal interest rate compounded monthly. So the interest rate that I want to work with is going to be I. So always be on the lookout for that. You must make sure your compounding period is the same as your payment period. All right, so here when I solve this equation, I get the 12th root of 1,08 is equal to 1 plus I over 12. So when we work that out, the 12th root of 1.08, I'm going to subtract 1 and then multiply by 12. So my nominal interest rate is going to be 0,0772. Don't round off, okay? And that would be 7,72% per annum compounded monthly. Right, so I'm going to store, this is compounded monthly, so in memory B, I'm going to put this 0,0772, etc., 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 divided by 12. All right, shift store B. And I had put 0.08, shift store A. All right, now we've got two different kinds of deposits here. We've got that 5,000 Rand, that was a one-off deposit, okay? So when I deposit that 5,000 Rand, it earns interest, okay, for a period of 3 years. It's a one-off deposit. Therefore, you're going to use the formula 1 plus I to the power of n. Now, in this case, it doesn't matter whether you use that interest rate or that interest rate. I'm going to use that one just to show you. That could be 1 plus A to the power of 3. Okay? 8% per annum compounded annually. Then what we're doing is we are going to add an annuity payment, 2,000 Rand per month, the end of the first month to the end of the 36th month. All right, so that would be 2,000, 1 plus, and here I have to use the interest rate that's compounded monthly. So I'm going to use memory B to the power of 3 times 12 minus 1 all over b. Let's do that calculation. Okay, so we have 5,000, open bracket, 1 plus alpha a, close bracket, raised to the power of 3. I'm going to write that down just so that you can check it as we go. 6298 56. Shift store C. I've put it in memory C. Then we have our 2,000 multiplied by, open bracket, 1 plus alpha b, close bracket, raised to the power of 3 times 12, move your cursor, minus 1, divided by alpha b, equals. And we have 80730 and 74 cents. So I'm now going to add that and the value I stored in memory C, and so the total amount of money that he would have after a period of 3 years is 87,029 rand and 30 cents. Notice I could have done that part of the sum using my monthly interest rate as well. That's perfectly possible. So you might just want to make your change in interest once, okay? So let me just show you that. We could have said 5,000, 1 plus b to the power of 3 years compounded monthly, okay? So 5,000, open bracket, 1 plus alpha b, close bracket, raised to the power of 3 times 12, and you do get 6298 and 56. Okay.